So we're gonna watch More Than Birds together today. We're gonna comment on it. I don't know how much I'm gonna have to say about it because this was another one of those videos that I feel like I don't know a whole heck of a lot more than is in the video itself. I guess one of the things that like it's just not a super big area of specialty for me. So it's not like this isn't something that I like researched for years. It was an idea that I had, and because I knew that birds were dinosaurs, and I thought it was cool. Why should we watch this? You don't have to, Soul Joe One. You can take off and do whatever you want. Yeah. So I guess one thing I can point out maybe as things go on is like more about like what exactly are the mechanisms by which things become the way that that dinosaurs became bird-like, because it looks like there was particular mechanisms for it, and I don't know how much I get into that. This is more like the way this is more just about the actual fact of it. But I guess let's just start it off, and we'll see what I think about to commentate as we go. So this is, if you don't know the song, it's Extreme, More Than Words. I decided there's a version of More Than Words by of Naturally Seven, who are great a great 7-man a cappella group. They had a viral video on an airplane that you might have seen, or maybe on a train, I can't remember. But their version was very influential to the arrangement of this version. But this one, you know, I'm trying to do some crunchy jazz chords and stuff. I got 7 voices, so it's a little bit of an homage to them. Hey, there's me. So the filming of this, like I don't really have a setting. This is why these are all the same chair, which you could probably tell. And I was just doing this in the basement where I film things, and the camera was actually really close to me, which I didn't realize would be a problem. But when people come to sit down, I like lean towards the camera, and my head kept getting huge, so there was a lot of like messing with the scale of things as I sat down in post, just so it wouldn't look super weird. But here's like, I think this came from a Peter Hollins. This idea came from a Peter Hollins video where he does a similar thing where like he starts with one person in a church pew, and then slowly like different versions of him come from different sides. It's a nice way to start, like build it up. Just me, I look a little awkward, but hey. Pigeons and doves coo, they're not two birds, but one from a deeper view. So that's a thing. I mean, right there. I think my my roommate at the time, Tom, had this idea for a Rent parody, which was Pigeons and Doves, based on Seasons of Love, just about how he had been lied to all his life that pigeons and doves were different things, and in fact they're the same species. And he never did it, and so I asked him if I could steal that opening line, the pigeons and doves thing, and he was like, yeah, go for it. With life that always holds true, one descent, but if you only knew how clear. I like the arpeggios. Gulls and geese have had their roots revealed. More than birds, the fossils have the clues to make it real. There's some crunchy chords in there for sure. What's going on here? So we're in F sharp and F sharp. I think that's the original key, because the original key, they like Extreme always tuned their guitars down a half a step. So their E's would be F's, or no, their E's would be E flats or whatever. So I think this is the original key, but there's definitely like, I didn't actually know jazz theory here, but I was still like messing around with just putting in weird things. And I arranged this one by piano roll on the computer. So I was like drawing in the notes, and I knew I wanted to have 7 parts all the time. So sometimes I would get to the end of a chord, I would get to a chord and be like, well, there's still a note left. I'm just gonna put like some weird spicy chord in there. So it's something. Moves to make. See, that's weird. It's like a It's this kind of walk up, which there's a diminished chord there, but make that's strange and dissonant, but it kind of works. Make it real. The clues to make it real. I've found that if you're tuned well enough, almost any combination of notes sounds okay. It's like when you're out of tune that it starts to sound weird. But if you're like pretty exactly tuned, and there was quite a bit of digital tuning on this to like make some of these chords work, because there was some of them were like that sounded good in my piano roll, but I can't nail it. So I like fiddled with it until it sounded right. Jurassic they had warm bodies and hollow airy bones. So I can't remember how people know that dinosaurs were warm-blooded, whether that came first as a discovery, or whether it was in like I could imagine that it might be based on like biomechanics of how much energy you would need to be a certain weight and a certain type of predator or whatever. It might be based on like the body type they have, how that body type radiates or absorbs heat, because that'll make a difference. Like if you're like an elephant has to spend a lot, like one of the reasons an elephant has giant ears is that it has to spend a lot of its effort getting rid of heat, because internally an elephant would cook if it didn't have a good way to release its heat. Because it's like, at the bigger you get, there's this thing called the square cube law, where there's only, as you go up by some order of magnitude in size, there's only the square of the amount of surface area, but the cube of the amount of volume, so you don't radiate as much heat. So there's a limit to how big a warm-blooded thing can be. And that's one of the reasons why whales can be warm-blooded and be larger than all terrestrial mammals, because in the ocean you can get rid of heat a lot more effectively. But I'm not sure whether it was that we discovered that dinosaurs were related to birds and then inferred that they were warm-blooded based on birds being warm-blooded, or whether it was more biomechanical. That could go either way. Airy bones, though, hollow airy bones, that's a thing. That is a true thing. In some dinosaurs, I don't think that's all dinosaurs, but like the close theropod dinosaurs, that was their adaptation for like ease of running on two legs, not for flying particularly. If raptors grew wings and flew more than birds, the stars. Yeah, so that's good. I'm doing that thing again with the 9 chord, like the stacked fifths. And burns the stones reveal. And then that's I think that's the chord I'm doing. So that's a A flat 7 9 it's basically an A flat 9 A flat minor 9 chord, but it's like the way you voice it with those two right next to each other, it's real crunchy. I like it. That's a real standard 2-5-1. Right. Yeah. Anyways. Archaeopteryx is real. Archaeopteryx, if you aren't aware, you're probably aware, but Archaeopteryx was the first winged dinosaur type or bird type lizard we found way back in the day. But it was kind of too far along. Like it was more like an early bird than like a late dinosaur, and people weren't convinced of the link, or like what the link was to Archaeopteryx. Like Archaeopteryx is like a proper bird, although it still has like a long lizardy tail. What would you say if I told you birds confess? That's another spicy one. What's going on there? Told you birds confess. Like the bass is doing. Yeah, I'd have to analyze that, because I don't know what I'm doing there. There's a lot of chromatic changing going on there, and I think I was just like, I don't know what those chords are. I never bothered to figure out. I just messed with all the voices until they like led where I wanted them to go. This is the thing that you can do a lot. Jacob Collier points this out a lot, that like in a like a transitional sequence like that, a lot of the time you can get away with like super dissonant sounding things as long as each one of the voices within the arrangement is like leading to where you want to land. It like if it like starts in a sensible place and then it can like go in all sorts of crazy directions, as long as like all the voices kind of have a melodic through line. It's called voice leading. And as long as they land in a good place where it like makes sense, then in retrospect your brain would kind of go like, okay, that works then. And I think that's definitely what's going on here.
If I told you birds convey more than eggs and tasty stew.
I apologize to the vegans and vegetarians, but birds are in fact tasty.
They're a strain of dino too.
Yeah, these sections are really like they're really inspired by the Naturally 7 rendition, especially because the originals. It's all chords pretty much, but the way that Naturally 7 arranged their thing was very similar to this with like it's kind of an arpeggiated. Like on the piano, it would be like, right, which kind of makes sense as a piano line, but you split it up within all the voices. So like each individual one is just like doing a couple notes, and they're like do 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 do, right? And it gives this like cascading, falling over each other effect. I like that chord.
How could life give rise to cockatoos from such a monstrous clan?
That's a weird sequence. Because like the original word is just do do do, right? Cockatoos from such a monstrous clan. So it's A flat to C flat to D flat to E flat, but I'm going cockatoos, something like that, which is shifting chromatically to A, and then to a D major seventh, walk up to like an A7. And then like a backdoor resolution from an E up back to the F sharp 7, which is I'm messing up all the sharps versus flats things, but yeah, weird. It's cool.
Such a monstrous clan. Selection, precious substitutes. Their jumps far glides to powered flight it tends.
Yeah, they're not sure how like whether the transition. There's a bunch of different possibilities for how the transition happened from like theropod dinosaurs, because like theropod dinosaurs developed feathers before there was anything like flight. The feathers came first. Like even like T-Rex has little like feathery things on its head. And what happened was Richard. So after I did this video, I did a podcast with Richard Prum, who's a ornithologist, and he explained to me that basically what dinosaurs invented to make feathers. They invented a tube. Birds invented the tube, or dinosaurs invented the tube, meaning that your hairs are like a solid object that it like extrudes from your skin, like I don't know, pushing plasticine out of a hydraulic press or whatever. But a feather starts out hollow. It's like a hollow hair, and then because it's hollow, that like it can actually separate around itself. So it grows in like a hollow bit, and then it kind of separates out like this and expands out into the feather, right? And so that's how you can get a complicated feather growing out of a very simple cell, right? And so that's pretty cool. That was a thing that dinosaurs invented. And it could have like the complicated structure of the feathers. It's very possible that it arose for like sexual selection reasons, like that it wasn't like people for a long time were like, oh, maybe it was to gain, to stay warm or stay cool or to like ward off predators or whatever. But like one of the big things that birds do nowadays is that they use their feathers as structural coloring and signaling and to make fancy gestures to each other and whatever. It's fun to imagine that maybe Tyrannosaurus could have been one of those tropical birds with all the crazy colors, like signaling to its mates. Because as soon as you get the capacity to create beauty, there's something that seems to attract like sexual, like organisms with any sort of brain will sort of fall down this rabbit hole of this cycling of like there's a little bit of beauty and that gets picked up by the other members of the species as like a little bit intriguing and interesting. And once a little pattern starts for beauty, it's self-sustaining because sexual selection can go in these kind of snowballing effects. The more your females say like something, the more advantageous it is for males to do more of it, which means the more advantageous it is for females to like the males that do more of it because their offspring will be males that do more of it that other females will like. And it's like a positive feedback loop. So maybe feathers are mostly a result of sex, and then they happened, and sexual signaling, and then happened to be used as flight things later, because evolution is the great recycler. I don't know. It's cool to think about.
Adapting old T-Rex's feathers and wishbone.
That's a weird chord, but I'm not gonna analyze it. I don't think. Yeah, T-Rex had a wishbone, which is it's like, I think it's this clavicle here. In us, it's two separate bones, but in birds, it's birds and old dinosaurs. It got fused into this one bone in the front that adds a lot of support to. I don't know. Like in birds, it supports their powerful wings and stuff. But I'm not sure if anyone knows what it was doing in T-Rexes. Maybe it's also helpful in standing upright.
More than birds, by Oviraptors breeding can be shown. 'Cause like birds, they laid their eggs sequentially inside of
Like that chord.
them to grow.
I like that. The chord at the end. Like that. I like that it's the bass is a 5, like it's like that kind of thing. But it doesn't actually have that bass, and I think it's just there. That's cool. You have to really suspended feel. Oviraptor. It was like the name Oviraptor means literally egg stealer, and the reason why Oviraptor means egg stealer is that for a long people discovered back in the day, the first Oviraptor was discovered next to a bunch of eggs, and it was thought that this Oviraptor had stolen the eggs from was an egg consumer, an egg thief, and this was like some other creature's nest, and the Oviraptor was like in the process of stealing the eggs or whatever, and got taken out by whatever it is that takes out fossil dinosaurs and froze there, and that's how they found it. So they called it Oviraptor, egg stealer. Later on, people found more Oviraptors next to identical nests and realized, no, it's like the Oviraptor, that was its nest. It wasn't stealing the eggs at all. Those were its eggs. But the interesting thing about Oviraptors is that they laid their eggs 2 at a time. So in all of their nests, their eggs come in groups of 2. So modern birds mostly lay their eggs 1 at a time. Like think of a chicken that sort of has like an egg clock. Like every day it lays an egg. But most lizards, like you've probably seen this in like frog spawning and fish spawning and stuff, and all the way up to lizards, like the way that if you've seen documentaries on sea turtles laying all their eggs in a nest. They do it all at once. They like build them up and then they go and all these eggs come out at once in one big laying. And so there was this clock mechanism that developed in dinosaurs and birds, and the Oviraptor is actually like seen from that point of view. It's a really cool and really indicative transitional fossil because you start out with many at a time, and then by Oviraptor you get it down to 2 at a time. So it would lay these pairs of eggs, and then another pair, and then another pair, and then they would guard them and sit on them. Like they've found Oviraptors that were like sitting on and guarding their nests. And I think it was the males who sat on the nests. Although it's always hard to figure out which one, because bones don't accurately tell the sex of things. You sort of have to make inferences about statistical patterns in animals of size and stuff, whether or not what you're looking at is the male of the species or the female of the species. But I think it looks like it was the males who did the sitting on the nests. So that was cool.
If you died while stuck in goo,
That line always gets a laugh when I sing it live.
more than birds in amber sealed, dino plumage is revealed.
Yeah, there were some recently before this was when the first like amber feather specimens were discovered that were like from raptors, from like theropod dinosaurs. Recently there was one that looked like, I don't know, I was talking to John about this because the news story was like world's smallest bird found, or like prehistoric bird or bird dinosaur transition found, and it was like they found a whole head of a little dinosaur bird in amber. But it seems like possibly that discovery was overblown. But yeah, if you go look up like dinosaur feathers in amber on Google, there's some pretty sweet pictures. Like you can the first evidence that we found of feathers in dinosaurs was like imprints in the rock. But in amber, you can see like the filament structure and like the little and branches off of branches that were in old dinosaur feathers. It's pretty sweet.
What would you say if our rooks and birds are the prey?
That's a really cool riff, but I think I took that from Naturally 7.
Are the
They had lice. Nice.
ancient kings made new? 'Cause they're avian dinos.
So one of the other things that happened when dinosaurs became bird, like probably the reason why birds survived was that everything big died in that extinction, and so these little tiny theropods that were already kind of in the process of transforming, just like all the little mammals survived, all the little birds survived. And it's something to do with just like the amount of, I don't know, the amount of effort it takes to stay alive as you grow. You need more. You're at the top of the food chain. You need a larger ecosystem under you to support you. These tiers of like every level down, there needs to be 10 times as many animals for them to consume, for you to consume. So top tier predators don't do well in like major extinctions because 50% wiped out at the lower levels is, well, I guess no, 50% wiped out at the lower levels is still okay. Just 50% at the higher levels, but yeah, I need to do more research into that, actually. I'm not sure why it was the little ones that all survived. But in any case, the little ones survived. They also grew to be very neotenous. So if you look at birds today, they look like baby reptiles. And actually, you can do experiments in chickens where you turn off the basically you turn off the inhibition for continuing to develop along the usual reptile plan, and you'll see your chickens like get a much like more protruding kind of crocodilian like snout, and they'll actually develop teeth in utero or in ovo, whatever you want to call it, because the whole plan for fully developing into like a reptile-like thing is still there. It's just being suppressed. So they're staying at this like neotenous, or like they're staying in kind of a juvenile form. It's the same thing you see happening in axolotls, I think, and like a lot of things. In fact, human beings are an example of neoteny. Like if you compare a human adult to like a chimp baby, we actually look a lot more similar to chimp babies than we do to chimp adults or like orangutan adults. Like adult apes look like they're like 500 years old if they were going to be humans. Yeah, and it's weird. Like it's often sexual selection as well that pushes you towards that, or like artificial selection. So like if like we have bred dogs for neoteny. Yes, Jan and Mamgusian are pointing this out. We've bred them for neoteny as a side effect of breeding them for like docility and wanting to follow us around and whatever, because little puppies follow their mamas around, and if you want to breed dogs that follow you around, you want to keep them puppy-like forever. So we end up with all these traits like the floppy ears and the short snouts and whatever that are puppy-like. It also makes them look cuter because we sort of have a universal, animals sort of have a universal cuteness detector for other animals that signifies that baby is early on the developmental program, because we all have the same developmental program early on. But yeah, like humans are pretty neotenous too, and in humans it was probably, well, like one of the things is that babies relative to their body size have a larger head. So if you're trying to fit a larger cranium into a small, like onto a being, you want to have a larger head. So for a larger brain, one of the best ways to do it is kind of to arrest that development where the jaw grows and the head stays the same size, kind of thing. So you just pull that back, and now we have kind of baby heads. The other thing is that like sexual selection can be a big thing for humans, for example. There's been a lot of research on like the preference for faces, particularly female faces, that we seem to prefer. Men seem to prefer female faces that look like children's faces, and I don't know what to make of that. But it's probably something to do with a correlation that it had at one point with something important. But again, with sexual selection, you can just get these feedback loops where if you prefer a young face, then your children will do better if they have young faces, which means other people's children will do better if they prefer even younger faces, and it just goes on, etc. So who knows? It's weird. But yeah, it seems like the ideal woman to the average man is like a child's face on an adult woman's body. So make of that what you will.
More than
That's a nice chord. This is why did I pause it there? That's such a good ending. This one chord, that woo woo, this whole section, it makes, this is the moment in the song. Sometimes there's a moment in a song that I'll just listen to the song for over and over because it just like makes my ears ring in a perfect way. This is gonna be that moment.
more than
That one chord. Cock-a-doodle-doo. What's that ending chord? Not bad. It's like a, yeah. It's just another major add 9. So yeah, there we go. There's More Than Birds. Should we look at the outro? Let's look at the outro.
Hey, musical scientists! This video was sponsored by Science Odyssey 2017.
Science Odyssey. They're like the Canadian government decided that they wanted to sponsor a video of mine. That's cool. Yeah.
From May 12th to May 21st, Science Odyssey is hosting hundreds of science and technology events all across Canada. Find out what's happening.
I don't think they actually, like, I don't think many people came out to that. I think it was like an experiment they were trying, and they were like pushing a whole bunch of support, like sort of new media awareness of it. But I honestly don't think I was a very good, I was a very good bang for their buck, especially because like YouTubers are such an international audience. Like the amount of Canadians that I reach who would actually bother to go out to a Science Odyssey event in Canada specifically, like you'd do better if you're gonna do YouTube targeting. You should target like Canadian YouTubers who have like a Canadian aesthetic and Canadian presence and stuff. I'm just a guy who happens to live in Canada.
Happening in your hometown by going to sciod.ca or following the links in the description. If you like this video, please consider subscribing. If you really liked this
See, you can hear the whoosh and the p that are coming in again.
video, you can support me on Patreon.
Oh, and I had
like
started
these lovely
I had started
also,
this
don't miss out on
podcast.
the next episode of Science Life. I talked to Yale ornithology professor Richard Prum.
Yeah, that's Richard Prum. Richard Prum is really cool guy. He's just like, he's one of these people like when you meet someone who's, it's obvious that they're doing exactly the thing that they're supposed to do in life. Richard Prum is that person. He's just so into birds. It's insane. Like he can talk, and it's like for good reason. Like he knows all these crazy, fascinating things about birds. The last book that he put out, I think was like going off of birds and into like beauty generally. Like how does beauty come to be? Because beauty is a thing that like requires a mind to observe it, and beauty is something that we see a lot in nature. In birds, in like those fish patterns, and there's something sort of universal about it too. Because our minds can recognize bird beauty, and our minds can also recognize like fish beauty, right? And so there's like something going there, like an emergent complexity that's appealing to minds generally and can evolve separately. And it's like a Schelling point. So I don't know, it's really cool. You should check out his book, because he's I think there's been not enough appreciation for the effect that mind has on evolution. We think of evolution as a mindless process, but that's only actually true until you develop a mind that's a mind within the animal that's doing the selecting, right? And as soon as you reach that point, then you go off the rails in all sorts of ways. So it's cool.
About bird sex, dinosaurs, the origin of beauty, and tons more.
Go.
My name is Tim Blay, and you're watching Acapella Science.
Acapella Science.
Mechanical bird. All right.